Hello students, in this video we are going to discuss about change of phase. In other words, we can say change of state of matter, like from solid to liquid, liquid to gaseous, and all these kind of changes. So first let us define what is the meaning of change of phase. Here, as I already had mentioned, it is the process of change from one state to another at constant temperature. Like in given diagram, you can see there are different arrows heading from one box to other. First look at the box of solid. So when we are providing heat to solid, on melting it converts to liquid. In middle box is shown. Further, if we are heating the liquid, it changes to gaseous state. Okay. This was on providing heat. But what happens when their rejection of heat occurs? Like if gas will reject the heat, it is going to lose the heat, then it converts to liquid. You can see arrow backward heading. Okay. So from gas to liquid by losing heat, and further if liquid loses heat, it changes to solid. So here I mentioned from solid to liquid, liquid to gas, and then from gas to liquid, and then liquid to solid. Okay. Other processes are also there that solid can directly change to gas. To this process we are saying sublimation. And then gas can change to solid. That is solidification. So these are the processes related to change of state of matter. Okay. So let us discuss about these all phenomena like melting, freezing, vaporization and condensation. Okay. So what is melting and freezing? Usually we are using a word that I kept ice out of the refrigerator and it got melted. So after melting, ice becomes water. Okay, that melting term is clear in your mind that when when solid changes to liquid state. So here concentrate on the definition. The change of solid to liquid phase at constant temperature when heat is supplied is called melting. Clear? Means which thing is occurring. Solid to liquid it is changing. And continuously we are providing heat to it. Okay, like you started melting an iron piece. Okay, you are providing it heat. Further, initially it will take heat to rise in for its rise in temperature. And after reaching its melting point, it will start melting. It will be going on absorption. The absorption heat will be going on, but there will be no rise in temperature. Okay. So I had mentioned here at constant temperature. When a solid changes to liquid at constant temperature, that phenomena is melting. And its inverse we can say the change of liquid to solid. Change of liquid to solid with the rejection of heat at constant temperature is called freezing. Look at the diagram given here. Here I am having 0 degree Celsius ice. Okay. During melting it absorbs heat because heat energy is required to provide kinetic energy in the molecules of the matter. Okay. So it absorbs heat and it converts into 0 degree Celsius water. There is no rise in temperature, only state of substance changed from solid to liquid. Solid is ice, liquid is water. And in backward direction, if we will see, rejection of heat, process is named as freezing. So water converted to 0 degree Celsius ice. Okay. Okay, let us move toward next topic. It is melting point and freezing point. So already when we were defining the definitions, when we were defining freezing and melting, that time we mentioned about a constant temperature. That constant temperature are melting points and freezing point. Look at the first one. Okay, first line, first point. The constant temperature at which a solid changes to liquid form is called melting point. And the constant temperature at which a liquid changes to solid form is called freezing point. Now we will talk about heating and cooling curves. What is the meaning of heating and cooling curves? Simply, it is a representation of change of state. Means when we are providing heat to a substance and with the time how its state changes, when we are representing it graphically, to that we are saying heating and cooling curves. First curve here we have to discuss is heating curve of ice. You can see y-axis is showing rise in temperature, whereas x-axis is showing time interval. Okay, from 0 to 120 second, you were having water at 0 degree. Sorry, you are having ice at 0 degree Celsius initially. Okay, and then we started providing it heat. Temperature is not raised for 0 to 120th second. Why? Where that heat provided went? Simply, that heat provided to the ice was utilized to convert ice into water. Means, in first 120 seconds, heat was absorbed for the use of change of state from solid to liquid. Okay. Okay, so till 120 it was showing only 0 degree Celsius. When full ice got converted to water at 0 degree Celsius, that time was at 120th second at point B. After that, water showed rise in temperature. Okay, from B to C. Means initially first full ice will convert into water, and then only it will show you rise in temperature. Now here I am with heating curve for naphthalene. So same thing here, x-axis showing time and y-axis is showing temperature. Naphthalene when kept at room temperature, nearly 25 degree. A point is showing you it is at room temperature. So initially from room temperature, at room temperature we said 25 degrees Celsius, it is in solid state. When we started providing it heat, it got converted to solid plus liquid state. But it started after reaching to point B, where temperature shown is 80 degree Celsius. Once it attained 80 degrees Celsius temperature, the solid naphthalene started converting into liquid. Means solid naphthalene is melting here. And during this time, from 90th second to 180th second, the heat was absorbed to change the state from solid to liquid. Okay. This process continued till full solid naphthalene got converted to liquid. And then after reaching to point C, again you can see curve is going upward. Means it is showing rise in temperature. Here it is cooling curve of naphthalene. You can see it is just opposite of the heating curve. Okay. So liquid naphthalene is at 100 degrees Celsius. On losing temperature it reached to point B. If you remember in last portion of this slide we saw that melting point of naphthalene was 80. So it reached to 80 degrees Celsius. Then this liquid started converting into solid. This continued till point C. And afterward, there is rejection of heat. Okay, and liquid, this solid naphthalene is showing afterward fall in temperature. Thanks for today. Stay home, stay safe.